Hi guys, welcome to our last part. I think this is the last part. We talk about productivity and everything related to operation management. Probably next in our next video we'll talk about other topics such as globalization, I think, and some other few interesting stuff. I've seen already some other comment about project management, and I really like to apologize to most of the comment that some people that are commenting asking for some topics that we have not yet covered. We will cover most of the topics there, but it's just that we already got a schedule of the content that we're going to produce. So if there's something that you are asking for, unfortunately, if it is not yet done, I'm sorry for that, but we will take time to produce most of the content there. So far we are following the schedule that we have already set for the content. Now let's jump in. Today we're going to try to look at productivity on a more practical level, and I just designed a small case study that we can use at this point here just to have an understanding of what of how productivity can be applied in your daily activities as an operation manager. So this case study here is talking about Mzansi service car. For those who do not know that are not located in Africa or even South Africa, Mzansi is just a common name that we give to the city of Johannesburg in South Africa. Now, there's this company that is called Mzansi Service Car, and they say that there's this manager who is Miss Nonhlanhla Miyake, and then she's the operation manager at the company. The company is located in Isando, which is actually another area in Johannesburg in South Africa. She is concerned about one of the branch main process and would like to analyze and recommend any change. Now she is preparing a quarterly report which is to include the productivity analysis of a branch. So actually what she want to do is she just want to analyze the productivity of the branch to see how the branch has been doing in terms of productivity. Now one of the input is production. One of the input is production data prepared by Sharon Gobeni, an operation analyst. Now she has prepared you with the following information on the production of a facility. So right now it's a report that she is making. So she needs to compare between bracket the different performance of the company. So now she's comparing the data that were in 2008 compared with the one from 2009. So she would just like to check in terms of the performance, how has the company been doing. Now in 2008, for example, the company was able to service 7,500 cars, while in 2009 it was only 6,000 cars. But now they've used some liters of a particular solvent. In this case, everything that comes down here, they are part of input. Remember that input, it is everything that a company uses between bracket to do what they are supposed to do, or to produce what they are supposed to produce. And in this case, the company is servicing cars. So we assume that servicing cars are output, yet the solvent here, the equipment, the labor hours, the capital invested, all of those are just input. Now, Nomtansla knew that a labor cost per hour had increased from 13 rand in 2008 to 14 rand in 2009. As you know, I think that there's always salary increase every year, I think by 8%, something like that. And you know that the economy with the inflation, prices always increase, they won't remain the same. Now, primarily due to a move to a management to become more competitive with a new company that had just opened a plant in the same area. Now, she also knew that a cost per liter, this is actually the cost per liter for the solvent here, it is increased from 320 all the way to 360 in 2009. And equipment renting cost has remained the same for both here. Actually, the equipment renting cost is, you can have some equipment that you are renting. One of those can be maybe a generator that you are renting. It can even be maybe a service tool that you are renting as well. So here they just give us a general cost, a general statement to say that these are the equipment that she's renting. Now she is concerned about the accounting process that increased a capital cost from 375,000 to 620,000. Now, but early discussion with her boss suggested that there was nothing that could be done about the allocation. So she would like to prepare, she would like you, which is you, but in this case it's me, she would like me to prepare or she would like us, yes, let it be like that. So she would like us, sorry guys, about some such notification. So she would like us to prepare with a solvent, equipment, labor, equipment, labor, as well as a multi-factor productivity figure for 2008 and 2009. Now she is wondering if the productivity increased at all. So she want to know in terms of productivity. Well, now at this point, you're looking at a normal individual. If someone just tells you that before the car was servicing, the company was servicing 7,500 cars. Now the company is servicing 6,000 cars. Do you think the productivity had increased? Looking at the output, other people will be like, no, but we have decreased our productivity because we are producing less. Before we were producing 6,000, now we are producing 7.5. So the output is decreased, but not the productivity. Remember, the productivity includes both the output and the input, and the input. And those are things that we need to assess right now. Currently, it's going to be difficult for us to determine if the productivity has increased or decreased, but the output, of course, it is decreased. But the productivity, we need to find out the calculation, and actually this is the purpose of this. So the question that they are saying here, they say that prepare a productivity part to report for Miss Miyake, and then she probably expects some analysis of productivity input for all the factors. Mostly they are talking about a capital productivity. We need to use 3 decimal places and the rest 2 decimal places. So whatever is for the capital, we will use 3 decimal places, and other other input we will use 2 decimal places. And she also said that whatever we can have like a multi-factor analysis, we need to use 4 decimal places. Now, what we have to do, let go down, let go up here. I'm going to try to copy this table, and we will work from this table here. So let me just try to work on a new table. So what are we going to do here? I'm going to say solution. Yes. So I'm just going to copy and paste this table here. The very first thing that we will do first is going to be a single factor productivity. Yes. Now, in this case here, I want us to remember one thing. Keep in mind that the formula is still the same. We say that productivity is equal to the ratio of your input over your output in this case here. So it's a ratio of your output over your input in this case. So we need to have this formula in our head as we are working. That is the only formula we're going to be using so far. Now in this case, this is between bracket the table that we got. Now we have the service. Let me try first of all to make this to auto fit to content so that we have enough space. Auto fit to content. Okay, it's not going. Let me just try to, yes, much better. Yes. So what happened in this case here? We need first of all to calculate the productivity, the how do you call it, the single factor productivity for each one of those items. Now keep in mind that you cannot calculate the productivity of an output. The productivity includes both the output and the input. So in this case, I'm going to add a new column here. So this column here, I'm going to call it the single factor. So I'm going to call it like single factor productivity, yet for between brackets 2008. Yes. So we are just calculating the single factor productivity here. Now, based on the productivity, I'm going to use this one here as an example as we will be working now. So obviously here we will just leave it empty because we are not getting any output this one. So we are working first of all the single productivity for the solvent per liter. The formula says that the productivity equal to the input minus the output. I'm going to try to decrease a little bit the size here so that we can be looking at, I think it's 12, 11. So that we just have something that makes sense. Yes, we have 11 here. So we know that this is the formula for the productivity. It is output over input. Then in this case, the output over input will be let me take this. So the output here is the number of units that they've produced, which is the number of cars that have been serviced. Then in this case, the number of cars that were serviced, it is 7,500 cars that have been serviced. Then we will divide by the solvent that we have used in this case, which is 700. Then we will still use the same formula for all the other items here. So I'm going to take for this one here, the output is still the same, which is 7,500. And then the input down here, we have 21,000. Then we do the same thing for the labor. In this case, it's still 7.5. That we divide by 42,000. Then we do the same thing for the capital invested. For the capital invested here, it's still 7,500. That we will divide by 375,000. Now, from the values that we've got here, now we need to calculate the productivity. Now, when I take 7,500 divided by 700, you approximately get a value of 10,71. Keep in mind, I think from the statement here, they had mentioned something like, let me go back to, they mentioned that the capital productivity only should be used to 3 decimal places and the rest 2 decimal places. So if I go down here, so this one here, I'm still going to keep it to 2 decimal places. This means that the company will be servicing the productivity using the solvent will be like, for every liter of the solvent, the company will service 10 cars. So it means that it's 10 cars between bracket per liter of solvent that has been used. So this means that when they use with 1 liter of solvent, the company is going to be able to service 10,71. Obviously, we can try to round it to 10 or to 11. So we can say that approximately 10 cars can be serviced with 1 liter of the particular solvent that the company is using. Now let's go down here. Now, as we look down here, we still have the equipment that have been used. It's actually in terms of hours that they have rent. So it's 7,500 that we divide by 21,000. Then in this case here, we assume that it's 0.35. Actually, it's 35.67. So I want to put 35.6 cars per hour. So this means that every hour the company is between brackets servicing 0.36 cars. Well, in an hour you just take that value that you multiply by how do you call it? Not in an hour. In a day. Let's say the company works in a day of 36. In a day of 8 hours, 36 times 8. It means that in a day the company can only service 2.8 or 3 cars between brackets using those equipment. In terms of labor, we were also talking about the same thing. So for labor is 7,500, we divide by 42,000. Then in this case here, the statement is where the company will be getting 0.18 cars per hour as well. So this means actually these are the hour rented, and this one here is the labor hour. So it means that in 1 hour, between bracket, an employee is servicing 0.18 cars. Then we do the same thing for the capital investment. The capital invested is 7.5 divided by 375,300, which gives us 0.2. This means that for every rent spent, actually we are using rent because that is the monetary value in South Africa, the South African rent. If you are in America, wherever you might be, you will use dollar based on the monetary value you're using. So this just means that in this case, the company is manufacturing 0.02 cars per rent. So every rent can between brackets service 0.02. So in a nutshell, this is what happens in terms of the productivity. So you see that we always take our input, we divide by the output. Well, this is what has been for the single factor productivity so I'm going to call it single, okay, I don't know what happens here. I'm going to call it single factor productivity. Now this one here is for 2009. So as you look at the table here, whatever we have here, I'm going to put it same color to know that this is just the productivity that had happened during this period here. I'm just going to give it the gray color here to say that this is the productivity for this period. I'm wondering why my table looks like this, but anyways, it's fine. Then I'm going to try, we will still use the same formula to calculate the productivity for 2009. Then in this case here, 2009, what happens is we have the output. The output is changed. It is not 7.5 anymore, but the output here, the company is producing 6,000, yet they are also producing 900. I mean, they are also the solvent. Before they were using 700, now they are using 900, yet they are producing 6,000. So you will take the 6,000 that you do have, that you divide by 900, which gives you 6,67 cows. So this means that the productivity of the solvent, we can agree that it is reduced, because before the company was producing with 700 liters, they were servicing 7.5 cows. But now with 900, the productivity has been decreased, and you can even see we are moving from 10 to 6 here. But let's proceed and find out. Then the output in this case is still the same, which we do have 6,000 that we will divide by the input. The input in this case is the number of hours that they've used to run the equipment, which is 25,000 in this case. So if you take 6,000, you divide by 25,000, you have a value of 0.24. Now the 0.24 here, 0.24, like this, sorry, it is actually the number of cars that is being serviced per hour of whatever unit or whatever equipment they were renting. Now in this case, as we look, we still find that there's been a little bit of a decrease in terms of here they were servicing 0.36, now it's 0.24. Now as we go down for the labor hour, in this case here, what is going to happen is we look at 6,000, because this is what the company has been producing, so like in terms of car that they've serviced, and then in this case here they've used 35,000. Now in this case here we are talking about the labor hour, so it's 6,000 that we divide by 35,000, which gives us 0.17. We have 0.17, like this. So this is between bracket the cars that are being serviced. So I'm just going to put it here car because it's 0. It's just spelling errors. I'm just going to say car. This one as well, it's a car. Yes. So in this case here, the company is actually serviced 6,000. We divide by 35,000. So it means that they have serviced 0.17 car per labor hour. Then in this case here, when we look at the capital that has been invested, the formula still remains the same. We look at the output, which is 6,000, and the input in this case here is going to be the capital that has been invested, which is 620,000. 620,000, yes. So I have 6,000 divided by 620, which gives us a value of 0, remember they said that we should use 3 decimal places. Then in this case it will be 0.0097. Well, I'm going to put 3 decimal places to make it 0.1 in this case, but fine, let's try to put 0.001. So in another way, this is what the company is producing here. So what is happening is the company is producing, you notice for the capital invested here, it is almost double. Well, it didn't double that much, but it has increased with more than 80%, yet the output is still the same. And that's why we're saying that in this case, based on the values as you can see them, you notice that there's been a little bit of a decrease. Now the problem here is just that as much as there's been a decrease, the major issue is just that we need to, actually for this one here, we can just even round it to 1 to get the value, unless I'm mistaken, because the value is 0.00, and then we have 0.96. We could say 997, like this. So actually, let me just put it like this to make it a little bit more accurate, rather than keeping it to with the other value as well. So yes, now the issue here is just that, yes, sorry, I was saying that the issue here is just that you look at what the company has been able to produce based on how much capital was invested. It is actually less. But the problem is, as we are working as a company, we need to make sure that we understand the value, because as we are production managers, so we know that when I'm talking about 10.71 cars and this one is 6.67 cars, we understand this is actually a concept that we can understand, but general managers do not understand that. Business owners do not understand that. What they do understand is money, percentage. This is what they do understand. So we need to be able to summarize, because remember, this is a report. We need to be able to summarize and check in case there's been an increase or a decrease in the productivity. Now, what we do, we call it, we're going to call it productivity increase. So the productivity increase here, this is what we're going to try to assess. There's generally a formula that people use. There are many ways that you can look at it, but personally, this is what I would suggest. You generally take the old productivity, the new productivity. I'm going to call it like this. The new productivity minus the old productivity, that we will divide by the old productivity. Well, remember that this is an increase, and we generally have to multiply it by 100%, just for us to have an idea of in terms of percentage. Now, let's take a look at whatever happened here. So when we say the old, is because we look at the second recent period, and the new is the most recent period. Now, in this case here, assuming that we are in 2010 or we are in 2009, this one I'm going to give it as well. This color. So whatever is, I don't even know which color is it. It looks like cream white. I don't know. Or I don't know. Yeah, whatever color this is 2009, and this other one that is grayish is 2008. So we just want to compare. Now, assuming we're in 2010, we believe that 2009 is between bracket the most recent. We will call it the new productivity, or even if we are in 2009, we call it the new productivity, and 2008 will be old because it's actually it's actually very old compared to 2009. So in this case, we need to compare the productivity. We will still use this formula here. So we will assume that the new productivity in this case, sorry guys, it's just that there was a meeting that was taking place and I was part of it. Okay, so in this case here, we have 6,67 minus so we have 6,67, which is the new productivity. Oh my goodness. Okay, so we have 6,67. This is the productivity of 29, which is considered as a new productivity. And then, oh my goodness, so sorry for this, guys. Yes, so we have 6,67. Oh yes, so we have 6,67, which is the new productivity, minus the old, which is the one from 2009 ish. What is this, guys? Can I just close all this? Okay, let's try. So my apologies again for the disturbance. So I was saying we have 6,67, which is actually the old product, the new productivity, because it comes from 2009. This is the one that we have. We will compare it with the 10,71, which is actually the old 10,71. It is the old productivity that we will divide by the old productivity again. Actually, it's not, is it 10? Yes, it's 10. So the old productivity will still be 10,71 in this case. So whatever value, we multiply it by 100 so that we can get the productivity. So if we take 6,67 minus 10,71, that you divide by 10,71, and if you multiply it by 100, you will get a value of negative 37, unless I'm mistaken. Yes, you will get a value of negative 32,72. So this means that between bracket, the company is underachieve or underperform between bracket, because we are looking, the negative sign just shows us that there's been a decrease in the productivity by 37. So before the company here, with the new changes that they have made here, it really affected the productivity of the company, because as you can even see, with 7.5 with 700 liters, we were able to service 7.5. Now with 900, we are only able to service 6,000. So what happened in this case is there's been a decrease of 37. Now we will try to take this and do that for the remaining values, just to have an idea of what happened in the productivity. Now for this other one, we will take 0.24 minus which is the old one, which is the new one, minus 0.36. That I'll divide by 0.36. Then in this case I multiply by 100. So my 0.24 minus 0.36 that I divide by 0.36, that you multiply by 100, which gives you a value of negative 33. Then it still means that there is still a decrease of 33% compared to what has been done before. So the principle is still the same. The principle is still the same here, just to say that, as you can see, you realize that the company was actually, with the 21,000 hours that they were renting, the equipment, they were able to service 7.5 cars. Now with the 25, actually there's been an increase of 4,000 more hours, yet the productivity has even decreased. So that's why we are saying that there's been a decrease here. Now we still do the same thing here, which we will take in terms of productivity. The one for 2009 is the new one, which means 0.17, minus this other one, which is 0.18, and then we will divide by 0.18. That will multiply by 100. Then in terms of value, here we have 0.17, which is the new one, and then here we have 0.18, which is the old. Then we divide by 0.18. The value gives us, we still get a negative value, and then if we multiply, we actually have a decrease of 5.55. I'll just put it 56. So it means that in terms of labor, there's been a decrease. As much as this guy have decreased the number of unit or the number of people or labor, because before they were paying 42,000 per labor hour, now they're looking at 35,000. So there's been a decrease, but yet it's still not enough, because we have decreased the labor, we have also decreased the number of units that we have produced, or the number of hours that we have serviced, unfortunately. So if we look at this other part, we look at 0.00097 minus this other one, which is 0.002, and then down here we have 0.002, sorry, 0.002 and not 3. Yeah, so what happened is like 0.0097 minus 0.002 divide by 0.002 and multiply by 100. Actually, this one here, there's been a decrease of 51%. So it's 51.5%. So this means that, as you can see, the productivity, the single factor productivity has actually decreased. We are on a -1. Everything is negative. If there was a positive value, it would have mean that everything that we got here between bracket, there's been an improvement. Unfortunately, everything that is here is negative. So as I'm leaving you the time to just look at everything that, to look at the video and to understand the single factor productivity, in the next video we will do the last part, which is the multi-factor productivity, just for you to have an understanding. Thank you so much for watching this video. Please subscribe to the channel, share. Thank you very much, and